Hello everyone, I am Gagan the BS from Data Science Department. So here of the topic is advanced regression model. So I am explaining the advanced regression model of the code. So here is the advertising is equal to pd.data frame pd.read slash csv advertising.csv. So I am giving the line by line explanation for this. So this is the loading the data set for the project. So explanation is this. Read the datasets from the CSV file, convert it from the pandas data frame at display and get a first row 5 rows of the inspect the data and advertising the head, and this is the so load the data for the from the CSV file. And next super warnings super warnings, import warnings dot filter warnings, and the import the numpy and the pandas, import numpy as np, import pandas as pd, as data visualization, import matplotlib pyplot as pd, import cborn as sns. So here warnings dot filter warnings ignore. So this is the it hides the unnecessary warning messages. NumPy and pandas. It is for numerical and data handling expression. Import matplotlib dot pyplot as PID. Import cborn as SNS. So this is the matplotlib plus cborn for the visualization, plots and chats. And next is advertising dot shape. So this is the advertising. Shows the number of the rows and columns. Means 200 records or for this 200 comma 4. 200 means it is records and the 4 ones means futures. So here next step is the advertising info. Advertising info. This shows the column names and data types and confirms there are no missing values. It confirms that there are no missing values. So in this advertising information, class pandas dot core dot frame data and the range index that is a 200 entries 0 to 0 to next advertising describe. It generates the descriptive statistics, mean std, min or max percentiles. Advertising dot is null sum and start the 100 by advertising dot shape. So double check missing values, common wise all zeros. And next coming to the checking null values, advertising dot is null. Is null is to the to determine the exception of the null, and dot sum into 100 advertising dot shape. There are no null values in the datasets and it is clean. And next coming to outlier analysis. This is the outlier analysis. Figure axis is equal to plate subplots 3 comma figure size is equal to 5 comma 5. So sn this belongs to this is the meaning of the sns dot blocks box plotter. Advertising tv ax is equal to ax0. Next plot 2 is equal to snx dot box plot advertising newspapers. Plot 3 is equal to sns dot blocks plot advertising radio. And the next plot dot tight layout. This explanation, it creates the blocks plots for each feature, helps detect extreme values. Result, this is the no significant outliers. The next is this is the outlier analysis. And the next, and this the box type and the blue color diagram. This is also a tv, this is for the tv diagram, and this is the newspaper, and this is the radio. This is the output of the outer analysis. And next part we coming to the sns dot blogspot advertising sales plot show. This is the output of this code. Advertising sales means this is the blogspot of the sales distribution. SNS dot pot advertising x wires is equal to TV, newspaper or radio. Y variable is containing the sales. Height is equal to 4. and the kind is equal to scatter. The plots show how each feature affects sales. Strong visible relationship between the TV spending and sales. So before I said let's SNS dot pair plot advertising X was TV, newspaper, radio, and there is height of the height is 4 and the accept is 1. Kind is equal to scatter plot. So this scatter plots how each feature affects sales. Strong visible relationship between the TV spending and sales. And next we came to, and this is the output of the TV and the newspaper and radio. So this is this view likes scatter plots, and this map like this is a map for scatter plot. And next we coming to the correlation between the different SNS dot heat map advertising the advertising dot correlation. C map is equal to YIGNBU. So cannot, this is true. Plot dot show. This explanation, heat map shows the correlation values between the variable. TV has the highest positive correlation with the sales. It's equal to best predictor. In this heat map, it shows the correlation value. The TV is a common value, like in the you can see that TV, radio, newspaper sales, and in the y-axis it is the linear from the from first option is TV, and the second is radio, and the third is newspaper sales. And here from the y-axis you can see the x-axis you can see the TV is 0.9 value, 0.35, 0.16, and this is from the rightmost side it is having the temperature. So this is the heat map. Heat map for the shows the correlation value between the variables we can see you can see the correlation value, some difference values. So next is x is equal to advertising TV and y is equal to advertising the sales from sklearn dot model. So this is x is equal to advertising TV, y is equal to advertising sales. We only use TV as a predictor for simple linear regression. From these two x-axis and the x-axis and y-axis, we can see the simple linear regression. From sklearn dot model selection import train x train x text, y train y test. Y test is equal to train test split x comma y train. So this explanation, 70% data is in training and the 30% is in testing. So let's now take a look at the train data set. X train data head. This is the TVs of the value and the x dot train head. This TV, the overall TV values are where TV values from by calculating the train size 0.7, test size 0.3, and a random state. So random state ensures that ensures that the same split every time. So this entire not entire this the heat map and for X advertising, advertising sales and TV, there is a splitting data for training and testing. So here 70% of this data is training and the 30% is testing. So this is the TV values and y train data by x train data, and d type is equal to d type float 64. Then by, we can see by the y train head data sales. This is the train data head, x train data head. This is the y train data head. From you can see the sales like it belongs to the y axis. Uh, so here are the values like x axis by calculating the Already I said train size 0.7, test size and random state. By all adding and the calculating with the same procedure and the rules, we can get the float 64. Next further part will continue by the algorithm.
Hello everyone, myself Yelguresh from GM University. Further part of the code is continued by me. Here we building a linear regression model using a stats model. Importing a necessary stat model API as SM. Xtrain SM is equal to SM dot add constant xtrain. This part explanation here. Add constant add interceptor means OLS is equal to ordinary least square regression. The LR parameter means interceptor concept. Intercepts a constant. Slope is a coefficient of a TB. Next, the model summary. The model summary is here is explained as the root square is equal to 0.816. A TV explains 81% of sales variations. P value 0.000. The TV is statistically significant. Coefficient of a TV is equal to 0.0545. Sales increases by 0.054 for each unit of TV spendings.
Hmm.
Next, visualizing regression line. PLT.scatter and PLT.plot shows the regression model, the actual visualization. The further scroll up. The further line shows here the ಸ್ವಲ್ಪ ತಳಗ. The further
Start.
Hmm. The blue points here shows the actual training data. The red line shows the predicted linear regression line. This is what is expected output. Next, the error analysis next will be continued. Here, the residuals is equal to actual. The residual is equal to actual minus predicted. The normal distribution of a residual indicates a good model. Next, testing the model. Testing model involves the code part here is error term is completed. Scroll up. Hmm. Next, next. This is x test. The as a statement comment says a constant x test. Here we are testing the model. We predict the predicts the sales of unseen test data. Next, model performance RMSE, which is calculated by root mean square error. Here we RMSE is approximately 2.019. The lower RMSE is a better accuracy. Next, testing the scatter plots. The PLT dot scatter, PLT dot plot, PLT dot shows the visualization graph. Scroll up. Shows how well predicted line matches the actual test points. The final scroll up.
Hmm.
Let me summarize the our whole code. We initially data load and cleaning, outliers and correlation analysis, train and test split, simple linear regression of a TV sales, statistical summary of a model, visualization of a linear regression line, residual error analysis, model evaluation using RMSE. Thank you for watching. Thank you.